In this video, we're going to go through practice questions dealing with logs, and our first question says, for what real value of x, if any, is log base x minus 6 of x squared equal to 2? So for this kind of question, we're going to have to make use of our definition of log and get it in exponential form. I think that will be the easiest. And if you remember that, when we have log base b of x equal to y, we can rewrite this as b raised to the y equals x. And that'll be a little bit easier to solve when we see that. So let's rewrite. We have our base. We have x minus 6 raised to the 2 equals x squared. So we want to expand out here on the left-hand side and square this x minus 6. And we'll get x squared minus 12x plus 36 equals x squared. We're going to subtract x squared over here, and what happens is those two cancel out. Let's move over here. We're left with negative 12x plus 36 equals 0. We want to solve for x. We get negative 12x equals negative 36. Divide through by negative 12, and we get x is equal to 3. And we were looking for the value of x, and that is 3. Answer choice D. Number 2 says solve for x, and we have log base 3 of x equals 3. So again, I'm going to make use of our definition of log and exponential form, and I'll rewrite this as 3, and I'm getting that from right there, raised to the third power, which is right here, equals x. 3 to the third equals x. So now we can just evaluate this left-hand side. 3 to the third is equal to 27, and that is our value for x. Answer choice K. Number 3 says, what is the value of x in the equation 2 times the log base 4 of 2x equals 4? So we're going to have to make use of our properties here that have to do with logs, and we want to handle this 2 out in front, because then I can write it from log form to exponential and solve. So remember, we want to condense this, and we end up writing this as log base 4 of 2x squared. We bring that 2 out from in front, it becomes an exponent, equal to 4. Now we can put this in exponential form, and we're going to say 4, that is our base, raised to the 4th power, we get from our answer, equals 2x squared. 4 raised to the 4th power is equal to 256, and when we square 2x, we get 4x squared. Don't forget to square that 2 as well. We have to square both terms. Let's divide through by 4. And we get 64 equals x squared, and that's going to give us a value of x equal to the square root of 64, which is 8. We could think plus or minus 8, but you can only take the log of a positive number. So if this was negative 8, that would put negative 16 in our log, and that does not work. So here x is equal to D, 8. Number 4 says, what is the real value of x in the equation log base 2 of 4 plus log base 2 of 2 equal to log base 5 of x? Okay, here on the left-hand side, we can do some condensing because we have the same base of 2. We can rewrite this as log base 2 of 4 times 2, which is log base 2 of 8, equal to our right-hand side, log base 5 of x. Now notice we have a base 2 on the left-hand side, a base 5 on the right-hand side. So until we get those the same, we can't really do anything. We're going to work this in pieces. First, let's look at our log base 2 of 8. Log base 2 of 8. Let's just say that's equal to y. We're just talking about the left-hand side. I can rewrite this as 2 to the y equals 8. What is the value of y here? 2 to the what power is equal to 8? Y is going to be equal to 3 because 2 to the third is 8. So we could, in place of log base 2 of 8, put 3. And that is equal to log base 5 of x. Now let's apply our log to exponential property that we know. We can rewrite this. Here's our base 5. 5 raised to the third power is equal to x. And we evaluate that. 5 to the third is 125. And that is what our value of x is, what we were looking for. That is answer choice K.